August 17th, 2017. 12:41 Coordinated Universal Time. 130 million light-years from Earth, two neutron stars finished spiraling into each other. In less than a second, the collision produced enough gold to gift-wrap 200 Earths. For the first time in human history, we were watching. A neutron star is what remains when a massive star dies and collapses. An object twice our sun's mass, crushed into a sphere about 20 kilometers across. The density is extreme. 1 teaspoon weighs 1 billion tons, and occasionally 2 of them end up orbiting each other. Eventually, gravity wins. They spiral in and collide. The theory that such mergers are where heavy elements come from dates to 1957. 4 physicists, the Burbages, Fowler, and Hoyle, published a paper that mapped the entire periodic table to its stellar origins. Gold, they argued, must come from something violence involving neutron-rich matter. In 1974, Latimer and Schramm proposed the specific mechanism, a neutron-star merger. Everyone waited for the evidence. They waited 43 years. As 2 neutron stars spiral toward each other, they lose energy to gravitational waves. The orbit tightens. The orbital period drops from seconds to milliseconds to microseconds. In the final moment, the 2 objects complete hundreds of orbits per second before they finally touch. When they do, the gravitational distortion is so extreme that space itself warps measurably at Earth-scale distances. August 17, 2017, 12:41 UTC, LIGO triggered. The next minute is the first minute of multi-messenger astronomy. 1.7 seconds after LIGO's trigger, Fermi's gamma-ray burst monitor detected a short gamma-ray burst. That 1.7-second gap became one of the most important measurements in 21st century physics. It confirmed to 1 part in a quadrillion that gravity travels at the speed of light, 101 years after Einstein predicted it. The physics happening inside the merger is called R-process nucleosynthesis, rapid neutron capture. Neutrons are flying so densely and so fast that atomic nuclei can capture them faster than they can undergo beta decay. Nuclei grow by brute force through regions of the periodic table that are otherwise inaccessible. The hard part is not iron. The hard part is everything heavier because it cannot be built by normal fusion. Gold, uranium, platinum, all require this specific, violent, short-lived environment. The ejected mass from G1 170,817 was about 1/20th of our sun's mass. Neutron-rich material flung outward at a significant fraction of light speed. Within that ejecta, Kaysen and colleagues calculated approximately 200 Earths worth of gold, 5 to 10 Earths worth of platinum, also uranium, thorium, the lanthanide rare earths, the periodic table's entire heavy element section, forged in the final tenths of a second of 2 dying stars. Halfway through, the 200 Earths of gold from the opening. Here's what it means for the gold that is on Earth. Every gold atom in every wedding ring on Earth was forged in a neutron star merger. Not made in the sun, not made in a normal supernova, made in an event like G1 170,817 somewhere, billions of years before Earth existed. The gold drifted through the galaxy for hundreds of millions of years. Some of it landed in the molecular cloud that became our solar system, and some of it became you. In the solar system, roughly 10 to the 22nd kilograms of gold exists across Earth, every asteroid, every moon, everything. A single merger yields hundreds of times that amount. The ratio tells you something uncomfortable. Our entire solar system's heavy element inventory is a thin fraction of one ancient merger's output. The rest, most of it, is still drifting through the Milky Way, unattached to any planet. The estimated rate of neutron star mergers in our galaxy is roughly 10 per million years. That means on average, one happens every 100,000 years somewhere in the Milky Way. Most are too far away to matter to us. Some are not. And the gold they forged does not stay where they forged it. 75% of the way through. The remaining minutes are what 70 observatories recorded on the night of August 17th. The LIGO alert went out within minutes. 70 observatories worldwide pointed at the sky simultaneously. By 11 hours post-detection, the Kilonova was spotted optically by the SWOPE telescope in Chile, in the host galaxy NGC 4993. Over the following days and weeks, the Kilonova's light curve followed Cason's theoretical R-process predictions with the precision of a physics textbook illustration. What remained after the merger is itself a mystery. The two neutron stars had a combined mass just above the theoretical limit for stable neutron star matter. Current best evidence suggests the merged object collapsed into a black hole within milliseconds. A black hole made from two dying stars. Nothing escapes it, except the gold and the radiation that were already flying. The 200 Earths of gold from the opening, that number is the measurement. And the uncomfortable truth is that even that underestimates what we saw. The gold was produced in about 1/10 of a second during the merger itself. The entire economic history of human civilization, every coin, every ring, every bar ever mined, is a rounding error compared to what one merger produces in a fraction of a heartbeat. And there have been millions of these. Across cosmic time, there is a small but real amount of gold in human blood, 0.02 of a milligram on average. That gold spent 130 million years drifting through stellar nurseries, gravitational wells, a supernova or two, before settling into a planetary disk, solidifying into a crust, being mined, refined, ingested. Every one of us is, in a measurable sense, wearing the jewelry of a dead star. Somewhere in our galaxy right now, two neutron stars are orbiting each other. Their orbit is decaying. It will always be decaying. In some number of years, maybe millions, maybe billions, they will touch. And the gold they forge will begin its own drift through the universe. None of it for us, but possibly for someone. Two neutron stars spiral toward each other, 130 million light years away. None of it aware, none of it hostile, just physics. If you had to guess, how many grams of gold are in your body right now? Drop your estimate below. The actual number is in next Friday's video.